This conference will now be recorded.
Welcome, everyone. This is Ghada Sarafi, AquaWatch Director. I welcome you on behalf of AquaWatch for the Water Talk. This is a series of talks that we have been having from the Early Career Society, and it turns out to be really the heart and the core of the activity for the talks that position this society in a great position with respect to the scientific work for GU AquaWatch. I give the floor to introduce the speaker to Alexander Castagna from University of Kent.
Thank you, Gada. Today we're going to have the presentation of Subhajit for their water talks. And Dr. Subhajit is an assistant professor. He is a remote sensing scientist in the field of optical and hyperspectral remote sensing for water quality, vegetation, and environmental management practices, working on water and vegetation spectroscopy, water quality monitoring, disaster management, and algorithm development. His work has been focused on disentangling and analyzing optical and hyperspectral spectra to better understand water quality for efficient water management practices. He is currently exemplified as an assistant professor at Rashtriya University. I'm not sure if I'm pronouncing it correctly, but the Indian Central University and the Institute of National Importance in India. Previously, he tenured a postdoctoral research fellow at the prestigious Remote Sensing Lab at the University of Southampton, UK. And beyond his research and editorial pursuits, Dr. Subhajit is renowned for his exceptional ability to cultivate and stay in fruitful collaborations with researchers and scientists globally. So, Subhajit, the floor is yours.
Right. Thank you, Alex. Thank you, the GeoAqua entire team and the management team for providing me a platform to present my work today, which is highly connected with the agenda of GeoAqua Watch. From a warm welcome to all of you for my talk. Myself, Dr. Subhajit Bandopadhyay, and I'm a assistant professor in geoinformatics and disaster management in Rashtriya Raksha University, which is one of the best university in the country in we're working in the national security, pioneering the different areas of research in terms of national security. Disaster is one of them. We also have a Center for Excellence in Disaster Risk Reduction at our own school, and it is one of the institute with the national importance by the government of India. And yeah, so I recently joined the institute as an assistant professor, and the talk that I'm going to deliver, which has been done in last year in 2022 end to 2023 beginning. So that's the work I'm going to present today. So let's begin with the talk, and my topic for today is on Earth observation based evaluation of activity induced. I would like to ask everyone to make much concentration on the word on activity induced water quality variations in the Ganges. So before moving to the talk, let's meet with our team. Myself, Dr. Subhajit Bandopadhyay, and I'm assistant professor at the university. My team was mainly with Mr. Arun, who is a geospatial application developer at Larsen and Turbo Technology Services in India. Mr. Ujjal, who was before in Indian Space Research Organization. Currently, he is an associate at Cognizant India, which is an MNC company. Here, he is leading with the geospatial technologies. Dr. Mridul Ghosh, he is also a lecturer at the Serampur College in India. And along with Dr. Rahul Devdas, he is a senior data scientist at IBM. Currently, he is working at Munich in Germany. So you all have a collaboration teams from India and abroad, and we developed the study with our throughout collaboration for quite a long time, and we are still working on the different aspects of water quality with our own expertise in the field of geospatial science and earth observation. So, before moving to the main agenda of my talk, I would like to give much more emphasis on the river Ganges. As you know, it is one of the largest river in the world, as well as in Indian perspective, it is the most holy river. From being an Indian, this is the one of the holiest river in our country. It's a great place for every pilgrimage, and it's somehow connected with the hearts of the people. Because if you look at the history, the civilizations in the region, in the particularly in the Indus in the Indian subcontinent, is developed in the deltas, in the banks of the river. So that's why it's called somehow the Indian civilization is built on the Indus Valley River basin. So all the peoples who living in the banks of the Indus River, it's called Indian. So this is how river is somehow connected very closely with the human life in our country. It's given not only for the water but also for agricultural purposes, for for the as a religion space, in the different aspects of life. Water is highly connected, the rivers are connected. So Ganges is the biggest river in India. It's one of the holy river in India also, and that is flowing through the plains of northern India to Bangladesh. So it originates mainly in the Gangotri uh, glacier, which is located in the northern part of the Himalayas, and it's moved into the different states of India, and finally assure at the country Bangladesh, in Bay of Bengal particularly. So the entire stretch of river Ganges is quite large. It's almost 2,510 kilometer. It's a long river, which is starting from the Gangotri glacier in the central Himalayas, and then covers to the Great Plain areas. So it's called in the Indo-Gangetic Plain, which is highly like highly yield in terms of cultivation. The agricultural crops in this particular region is highly yield for their productivity, is because of the deposition of the soils in the like mid order and the lower order of Ganges, which is highly fertile in the land. And that's why the agriculture in this particular region in the banks is highly yield and very productive in the sense. So mostly in the paddy, wheat, and the different types of cereals and all. So finally, it drains into the Bay of Bengal through the vast delta in the Sundarbans. So Sundarbans, if you know about Sundarban, is it's a part of some parts comes under India, but majority comes under the Bangladesh. And the Sundarban Delta is one of the biggest deltas of the world, because of the one of the major island with the highly diverse nature of ecosystem. It's one of the global biodiversity hotspot of the world. And when Ganges reach to the Bay of Bengal in the sea, and the Sundarban Delta is located at the end of that. So if you look into the picture, so it is located somehow in the downside of the state West Bengal. So this is the if you look into the map, this is the entire stretch of Ganges, and the different tributaries are have been mixed with Ganges in the time when it come to the Devaprayag and Rishikesh and Haridwar in this particular region. So different small to small tributaries coming to mixed with the mainstream, and then it names as a Ganga, or in local language is called Ganga. It's the Ganges in English. So this is the entire strait. The majority of the part is flown through the state of Uttar Pradesh, where then it comes to the Bihar, and then come to the other states of West Bengal, and finally at Farakka, the Ganges divided into two parts. One part moving to the Bangladesh, it's with the name of Padma, and another part with the name of Bhagirathi, and somehow it's called to the Ganges also, goes down and mix with the Bay of Bengal. at the end. So this is the entire stretch of Ganges, which is almost 2,510 kilometer long river basins. It's a huge areas of watershed, and yeah. So the now one of the major challenge in Ganges in the over the time of period of time with the climate change and all this kind of environmental changes over the time, it's very crucial that government understand that being a holy river in India, being highly so many millions of populations dependent on the river, with the values of that, government of India started the mission. It's called the Clean Ganga project. It's called in a local language the Namami Gange. It's a conservation mission of Clean Ganga to improve the water quality, improve the different activities along the banks of Ganges is a major project. So why being is required to do a Ganga action plan? The plan is also comes under the umbrella of United Nations Environmental Program. So majority of the region is the environmental degradation. So it's if you look into the entire trajectory of Ganges River, there are lots of industrial discharges and untreated sewage and other pollutants that are mixing with the Ganges in the different location of the time, in the different through the different tributaries, through direct channels and all. So this is one of the major reason. Major Ganges is also one of the major source of drinking water for the large population in India. So when you are talking about the large population of India being a drinking water is always a concern for the public health. So that is one of the major reason. Most importantly, the cultural and religious impact. So as I mentioned, that Ganges is the holiest river in our country, and it holds a very strong cultural and religious importance, and have an immense like significance. The Ganges considered itself as a sacred river. One of the major reason is the economic impact. So lots of marginal communities and the peoples living in the banks of Ganges is highly dependent on the different kind of economic activities, particularly the agriculture, fisheries, and other various economic activities in the time. So this is also in the concern that to clean Ganga, to take the projects. Biodiversity, it's a huge, as you see the stretch is almost more than 2000 kilometer, 2500 kilometer. So it's a huge variety in the different stages of Ganges, from the higher order to mid order to lower order. You find the huge variety of floral and faunal diversity in the river. So to keep the biodiversity, to enrich the conservation practices, it's also important to look into the projects like that. And finally, as we're moving forward in a climate change and lots of in the perspective of the sustainable development goals by the UN, it's also our commitment to make a sustainable practices of water, and that's the another reason. So in a nutshell, if I talk about the Namami Gange project, was launched in 2014 and 15, which is assured amount of 20,000 crores. It's around 2 billion funding is assured by the government of India. There are lots of small to small projects, big projects are running on. Almost there are 344 projects which is sanctioned under this program. Till now, that many like 147 projects have been already completed, and remaining are other projects are under the execution. So if I give an example of one of the projects, for example, if the Ganges is flowing through some of the cities where the industrial wastages are very severe, and the channels are very polluted, so government is identifying those kind of channels, try to like stop this kind of mixing of the water with the industrial pollutants and all, to different it's about the entire stretch of Ganges. So this is one of the one of the example of the project. So this is one of them, but there are lots of other projects that's going on under this umbrella of the Namami Ganga, which is one of the conservation mission of Clean Ganges. So in our study, we mostly focuses into the three locations, and the speciality of the locations is the activities of different locations. So as I mentioned, the Ganges covers a huge stretch, almost 2,500 kilometer entire trajectory of river Ganges. So different parts of Ganges are associated with the different activity zones. So, for example, here there are lots of activities that's going on. From it's a one of the pilgrimage sign, as I mentioned. It's a holy river, so lots of pilgrimage people are coming into the river for take a holy bath like that. It's also a different kind of activity zones which is going on in the different parts, and finally in between that there are lots of industrial regions where Ganga passes through. There are huge, highly dense urbanized areas where Ganga is passing through. There are lots of agricultural land from where the water has been irrigated and through to the local croplands. So there are lots of activities that are happening in the banks of Ganges. If I look in from the higher order till the lowest order in the estuaries. So, but we in this study we are not covering everything. We are only covering the three major activities. One is in the Haridwar, which is located in the state of Uttarakhand in India. It comes under the first order of Ganges. It's a pilgrimage site, and in the second order, we consider the Varanasi, which is again a very popular place in a tourist destination. It's also mostly the pilgrimage site, and also it's a activity site. What kind of activities? Mostly the boating and other kind of water activities which is going on. And finally we took the Sagar, which is close to the, like, it's an estuary of Ganges, where Ganges mix with Bay of Bengal. So you can see the small satellite capture where Ganges mixing with the Bay of Bengal. So this is the Sagar, it's called the Sagar Island, and this is the estuary. So this is the major basic uh, the selection of the study sites. But in our extended study, we also covered the other places also, like for example the industrial locations, agricultural practices, some urban drainage locations. So these are other 7 or 8 other activity zones we considered for the study. But as of now, for this study, for this presentation, I am showing only 3 of them. And this is the major concern for this study, and would like to know about what are the major things that happening in a pre and post COVID situation, how the water quality looks like in these different activity zones, and if it is improved or not. So that's the major objective of this study. So if I look into the spatial location of the entire stretch, so you can see that from the higher order, it is in the north Haridwar, to in the mid you see the Varanasi, and in the south it's in the Sagar Island. So this entire blue shade area over the country is actually showing the watershed region of Ganges. So you can see that it's covering a huge area, and flowing through a lots of kilometer, lots of small to small tributaries are mixing with Ganges in this particular region. And so this is the entire specially plotted locational information of water, like watershed region of Ganges. Okay, now coming to the big technical part of the study, that we showed that remote sensing and earth observation science is one of the important like technique and significant nowadays for water quality monitoring. So this remotely sensed data, or particularly if I say the earth observation satellite data, is being utilized to monitor the water quality for many researchers, and particularly for the policymakers around the globe. So it's a very common and very popular practice in that. So if I look into the mechanism, how the things are going on, so I will come into the basic fundamentals of remote sensing, that how the system works. So when the solar radiation reaches to the water surface, there are three mechanisms can be happen. The energy can be absorbed, it can be transmitted, or it can be reflected. So based on the reflection, or based on the reflected energy which is captured by the different kind of sensors. For example, it could be a satellite sensor, it could be a airborne sensor, it could be a UAVs and all. So they're actually capturing that reflected part of the energy. But when the energy is coming to the surface and reflected back to the sensor, captured by the sensor, there is a huge role played by the atmosphere. So in between that, the use, like that in atmosphere is full of with lots of particles and gas and molecules, the water vapors and lots of things. So there are many kind of scattering, absorption, this kind of happenings are going on in the atmosphere. So atmosphere plays a crucial role, and if you are a bit aware about the system, you probably know about the terminology about the atmospheric window. And this atmospheric window is actually helping in the remote sensing studies, where this kind of absorption or scattering is actually very nominal. It's actually very less considering the other parts. So this part where absorption and scattering is very less in this atmospheric window, the reflected energy can pass through and successfully reach to the sensor, and from there the images has been taken. So but for water purposes it's very challenging, because water is a very dynamic terrestrial ecosystem, in the aquatic ecosystem, that there are lots of reflections can be done, sometimes the different kind of water, if it is a turbid water, the reflection properties would be different. If it is a shallow water, it would be different. If it is a very clean water, the reflection properties would be different. So based on the properties of the water, their density, turbidity, context, the scenarios and all, the response of the energy is different for them. So therefore, in remote sensing of aquatic water quality monitoring is very challenging in sometimes. But nowadays lots of improvements have been done in the science arena, and lots of research have been done in this particular domain. And very importantly, which I mentioned, that the scientists are able to manage to develop the different parameters of water quality. For example, the chlorophyll, dissolved oxygen, suspended solids, dissolved substances, and this suspended particle matter concentration, CSPM, which is our study mainly, and also pH. So there are lots of different kind of water quality monitoring parameters can be measured through the remote sensing study. And in our study we mainly focusing on the suspended particular matter concentration, which calls the CSPM. Is one of the most significant water quality parameter, because it's very crucial to many biological cycles and carries out a significant ecosystem related activities. So CSPM is one of the major water quality parameter, which have a strong connection with the biochemical cycles, and it's carried out a very important role in ecosystem activities. So it's not only about the water quality, but also the aquatic like lives and systems, how these are working. And in CSPM plays a crucial role in that. So so this is the entire scenario. If you need the fundamentals, if I look into the fundamentals of the system, and how the water quality monitoring works using the system of remote sensing and earth observation. So in this study, we have used the Sentinel-2 data. So Earth observation data is mostly there are lots of data sets in the Earth. If I look into the NASA, there are lots of satellite sensor. There are European Space Agencies, the Indian Space Research Organization. So there are lots of multispectral and hyperspectral satellite data sets are available in the market, and which is publicly available, free to all. But in this study we actually focused on the Sentinel-2 data. Sentinel-2 is a Copernicus Sentinel-2 data, and this is one of the system that developed by Copernicus, in particularly with a high resolution, and works under the optical domain. And there are lots of it is have a lots of applications from agriculture to land ecosystem monitoring, forest work, and water quality monitoring, disaster mapping, and civil society. There are lots of applications that have been done. So the reason behind the Sentinel-2 is very popular among the globe is because of the high spatial resolution. So basically, if I talk about the spatial resolution, and this is comes with the 10-meter spatial resolution. Some of the channels comes with the 60-meter to 20-meter spatial resolution, but majority which is actually need of the different application is covers mostly the 10-meter or 20-meter spatial resolution, which is very good in compared to if I talk about the Landsat, it comes with the 30-meter spatial resolution and all. So the entire Sentinel-2 satellite is constellated with the two different sensors. Number one is Sentinel-2A, and another one is Sentinel-2B. So Sentinel-2A is launched in 2015, whereas Sentinel-2B launched in 2017. And these two satellites are revolving around the Earth in all over the time in 24/7. But it's in the different parts of the world where the daytime is available. So being an optical satellite is highly dependent on the solar energy. So where there is a daytime, the satellite particularly passes through this region. If I talk about the Indian context, the overpass time of the satellite is around 10 morning 10 a.m. to 10:30 a.m. Within that time, when the solar radiation is high in this, like I will not say high, it's available in the region very prominently. So if you look into the structure of the Sentinel-2 bands, so there are total 12 bands are available, where it mostly comes into the coastal aerosol band to blue, green, red. The most beautiful and it's very useful for the agricultural application is for the red edge band. So you can see there are three red edge bands are there. There are near infrared bands are there. So there is also a red edge specific 8A band. There is also water vapor and shortwave infrared bands also available in from channel 10 to channel 12. So this is one of the unique set in Sentinel-2 that provides a huge number of channels from till band 12. And but for our study, we actually need the in the study we required both the data sets from Sentinel-2 and Sentinel-2B imageries with the spatial resolution of 10, 20, and 60-meter to get the glimpse of like to estimate the CSPM in the water. So if I talk about the calculation of CSPM, I will come into the methods. But if I look into the spectral range to capture the CSPM estimation of CSPM, it's mostly covering within the 442 and 2201 nanometer. Within this particular spectral range, the CSPM variations, and even in the inland water studies, where if you want to capture the CSPM, this is the main spectral range where this plays a crucial role. So the entire operations of the entire task is managed in Google Earth Engine. So Google Earth Engine is a cloud computing platform. If you are aware about that, it's a already pre-existed data set which is available in the Google Earth Engine, and it is mostly working with the JavaScript and Python API. And there is, you can see in the picture, it's a very powerful and useful code editors are there where you can directly code your works, and you can directly map the areas in your console. There are different tasks manager. There are lots of, in the right hand side you can import different assets. For example, if you want to import some specific shape files and all, there are many Python libraries you can use into the study. So this is also available in this. So in the entire study we use the Google Earth Engine cloud computing platform for the water quality estimation and all this like further operations. So in the modeling of CSPM, we actually applied the four different types of CSPM retrieval methods. and which is mainly covered in the Sentinel-2 dataset from the Sentinel-2 MSI multispectral sensor imaging sensor, and there are 4 different types of CSPM retrieval method we applied in our study. And as I mentioned in the previous slide, that in the 4 CSPM retrieval methods were applied in both Sentinel-2A and Sentinel-2B images to retrieve the CSPM values in the river Ganges during the 3 period of time, like pre-COVID, during the COVID, and post-COVID. So we considered the year 2020, and which is before the COVID situations, during the COVID and post-COVID situation, how the models are working. The models have been applied in the different specific regions of interest, which is called the regions of interest, it's or ROI, and the 3 selected locations. So it's on Haridwar, Varanasi, and Sagar. All these 3 locations we selected and where we applied our models. And there are 4 different type of CSPM model, retrieval models we applied in this study. So this is the again the small table that is showing into the different models. So from our end, we developed the CSPM model 1 and model 2, which is B4 and B7. It is actually showing the band 4 and band 7, where R is actually representing the specific spectral band. So if you carefully look into the bands, that in the band 4, which is covering the 660 nanometer in the model 1, and if I look into the formula that which is mentioned here, that we applied the exponential function with 19.53 into the values of uh, the, the reflection at 660 nanometer in this band, and it is covered under the range of 1 to 300. Similarly, for we also applied the same model at 760 nanometer, which is the band 7. And the band 7, we simply multiply the band 7 values at 780 with 2950 and with to the power 1.357. So, and this is the example like where it also looks into the values of 1 to 300. In the model 3 and model 4, we applied some of the pre-existing studies from Chow et al. And Hay et al. So where they applied actually the 660, but with some different equations. And for Hay et al., he also applied 2 different patterns, 745 and 490. So 2 different spectral regions he applied in this study, and this is the equation that is mentioned about that. So so there are 4 different models that we applied, and first 2 we applied for our own, and 2 of the studies has been taken from the other sources. So this is the entire stretch of the different formulas which is actually applied in Google Earth Engine operational platform to estimate the CSPM concentration into the Ganges in the 3 different locations of Ganges. So now if I come to the results and the observations, I will come one by one site for the results and observation type. So first I will come to the Haridwar, which is one of the pilgrimage site, and our first result is on the spatiotemporal modeling of CSPM, how the spatiotemporal fluctuations have been occurred. As I mentioned that it is mostly covering the year of 2020. So in 2020, you can see in the x-axis that the year 2020 is there, and it's from January till December, and the red dots is actually showing the different phases of lockdown. So in India, we have a different phase of lockdown, even not only in India, but in a global context, we are going through different lockdown positions where the human movements, mobilities is almost stopped in these regions. And if you look into the trends, okay, before going to the trends, I will also would like to emphasize that the Sentinel-2 revisit time in a particular location is on the 5 days. However, it is very challenging to get the quality data because of the cloud coverage, very noise and hazes in the satellite data. This is also a challenging factor. So therefore, in this study, we only considered where we received the quality data, availability of the quality data with concentration of less than 5% cloud coverage of that particular area, with minimum haze and noises into the data that we used for this study. So here you can see that lots of fluctuations in the data set, but more or less the trend shows a similar, except the Hay et al. Study, which is showing actually during the lockdown time the fluctuations are quite high. So this is something interesting that we find out, but mostly in the other, like the model based on B4 and model based on B7 and Chow et al. All three models are showing actually similar trend during the time of lockdown, which is actually very low, and most of the patterns in the other places is also showing the similar trend. So this is the entire spatio-temporal work. But now if I look into the ROI based, ROI means the region of interest based, so it's not possible to consider the entire Haridwar region or any other region. Therefore, we took some of the regions of interest where we have done the ROI based spatio-temporal modeling of CSPM. And so before moving into the images maps, I would like to tell you that these maps are based on the quality and data availability and time average. So it is actually based on the quality data availability, and finally it's also the time average of that particular time. So pre-COVID time and during COVID and post-COVID time. So here you can see that different models are showing up different images like pre-COVID, during COVID and post-COVID situation, how the water qualities varies. And even in this small ROIs, the concentration fluctuations are very prominent. So if you look into the pre-COVID situation, there are some of the concentration are higher in, which is showing in all three models. If I talk about uh, in the southern part of the images, whereas in the during the COVID time where activities are normal, that you can see the images are showing mostly the similar results with the very low concentration. But however, in the post COVID where activities again started in the different human interventions and these places are become crowded, the concentrations of the CSPM is also increased over the time. So this is the overall images in the Haridwar. So what are the key observations from the Haridwar side, in the pilgrimage side? That the result shows a considerable amount of CSPM was found in the Haridwar in a post-COVID situation. Particularly the southern part of the study is noticed with the high concentration, as I mentioned, in the post-COVID, even in the pre-COVID situation. Um, it's important to see the remarkable changes in CSPM observation during the COVID, and during the COVID, this is because of the like less mobility. Almost peoples are at their home in the lockdown situations. So the movement of the people, there is no pilgrimage activities has been occurred in during that time. So that makes a qualitative improvements in the water quality of CSPM, particularly again in the southern part of the study area, which is actually the high concentration of CSPM has been found. It's actually low during the COVID time. But situations are showing again worst. It's increased in a post-COVID situation where activities are normalized, people's lives are getting normalized, activities are normalized, and subsequently the increasing trend of CSPM has been found in the southern and the central part of the study area in the Haridwar site. But mostly all the four major results are showing a similar outcome with the very nominal diversions has been found. So similarly, if I look into the Varanasi, it's actually again a pilgrimage site and also an activity site. So there are lots of water activities are going on in this particular area. And again, this is a 5 days data set, and the trend of the quality of the trend is showing the similar, like based on the 5 days, but we develop the time series data based on the quality data availability. And in this model you can see the Hay et al is showing actually the high amount of outcomes, whereas the other three models are kind of a similar trend that's following. It is interesting that in every lockdown phase the Hay et al model is not perfectly working. this is showing the high concentration, whereas the other three models are come with a very low concentration in the time. So which is actually observed in Haridwar is a similar kind of model outputs that we observed in the Varanasi also. If I look into the pictorial description and the ROI based modeling, in the ROI based modeling, we can see that the concentration mostly located in the pre-COVID in all these three places, in all these four models in the northern part of the study area. And whereas during the COVID, you can see the water quality is bit improved, but except Hay et al. In the Hay et al, it is again showing some of the, like the concentrations are quite higher in a Hay et al, but the rest of the other three models are showing the improved water quality during the COVID. However, in the post-COVID situation, the situation are getting bit worse, I would say, that the water qualities are very, very less improved over the time. And this is showing in a time series average of that particular region of the particular ROI of the study site. So the key observation from Varanasi, that in the pre-COVID situation, again, it shows a very poor water quality with a severe concentration of CSPM. In the post-COVID, it is that the central and the northern tip of the sites are increased with the post-COVID because of the activities are increasing over the time in the post-COVID situation. And during the COVID, the water quality site is significantly improved, and majority of the areas is under the low concentration because of the less human activities. Models are showing almost similar outcomes with a very nominal divergence. If I exclude the Hay et al. Model into that. Okay, but it's very interesting to look into the outcomes in the Ashuran region. So you can see the time series graph. There is, I would not say it's a very typically followed by each and every model properly, because it's a very interesting, because it's the Ashuran area and mixing of the water in another scale. Not only Ganges but also the other rivers are floating in this area, and it's a huge delta region where the water is not in a very singular channel that is moving around, but also it's mixing with the ocean. And so there are different kind of water are mixing in a particular press, from a salt water to fresh water. There are lots of the inclusions from the different like the delta region, like soil, the nutrients that are coming from the regions and all. So this is very dynamic, hugely dynamic Ashuran area, I would say. And that is, it's very tough to get a proper picture of that particular area to find out a CSPM concentration in all four models. But however, as it is also showing that all three model, mostly, if I would say that, if I look into the trends of the graphs, that mostly the three graphs are showing is a similar kind of results. However, the Hay et al. Is a bit different, but it's not so prominent like the previous one. And if I look into the spatio, like ROI based spatio-temporal modeling of the CSPM, that in the pre-COVID and during like pre-COVID scenario, all these things are quite the concentration of CSPM is quite high, whereas in the during it is much improved in all the conditions. Whereas in the post-COVID scenario, the due to the activities, increasing activities of the CSPM, and it is increased again. So this is the overall picture into the area, but it is still very, I would say, much more research is required, because of the lots of things are going on in a particular Ashuran area. And it's not very significant to say very strongly that this is the picture actually on. But this is the overall glimpse that we received from CSPM into this particular region. So if I look into the key observation of the Sagar, and that's considerable parts of the sites are under the very severe to severe CSPM, and more particularly in the northern and the southern and the western part of that particular ROI, it's actually like very severe conditions of CSPM has been found. During the COVID, the quality of the is improved. We found that very less CSPM concentration in this particular area. And in the post-COVID scenarios, the CSPM observations in the western and the eastern part of the sites are very higher. Mostly the four models are showing a similar outcome with the way, if I remove the very nominal diversions have been observed. So take a home message from my study that Earth observation can categorically estimate the concentration of suspended particulate matter concentration, which is CSPM. Definitely with the other pollutants, we also have done the study on the other pollutants apart from CSPM. We also did from the turbidity, pH, dissolved oxygen, and other concentration. We also able to capture through the Sentinel-2 data, and that's why I mentioned that Earth observation is a very important thing. When you look into the synoptic view of a particular region, it's not possible to make a in situ observations when for a larger river like Ganges and other rivers. So there here geospatial technology and Earth observation data sets make a very important role to capture this kind of concentration of the different pollutants of the regions. Secondly, the dynamic nature of changes in the concentration highly depending on the region and specific circumstances. So it is the main region that we mentioned about the activity zones and activity induced. So most of the three locations which is highly human activities are engaged in, but during the time of COVID and all, the scenarios are changing, and that's why I mentioned that the changes in the concentration of CSPM, even in the other also, that highly depending on the region and how the specific circumstances plays a crucial role in this category for this. The major reason of the improved water quality is the reduced tourism and recreational activities, decreased transportation, and shutdown of the different activities is the major reason of the water quality. That so the situation get back normal in this particular in the all activity zones, which is majority is the pilgrimage site in the even in the Ashur region. In because being I am belong to that particular state of India, I know this, but this Sagar Island is a very popular tourist destination for and this is because of the COVID-19 lockdown, during the reduced tourism, different recreational activities, and other transportations and all kind of water activities has been stopped in this area, and which is the major reason of the water quality improvement in all these activity sites. But I would say it's very important to note that why we are doing this kind of temporary improvement studies and water quality in the initial stage of pandemic long term, we definitely, it's important to look into their long term variability, how these things are working in a very long term, and in the initial stages of pandemic, it definitely shows a very improved result, but it is important to how the things are going on. If this time series would be for a longer period of time, that may very important to understand how the improvements are going on, how the operations are going on, what are the different kind of stages or schemes that has been taken by the different agencies to the improvement of the water quality in this particular scenario. So as societies resume to normal activities, and the crucial to maintain the focus on the sustainable practices and environmental conservation, and to ensure the continued water quality improvement. So that I mentioned that we observed in the post-COVID scenario, when the normal activities being resumed, the concentration of CSPM is increased again. So therefore, it is not possible to make a lockdown for a long time, which is absolutely not possible. But it is also important to look into how the intervention of people's activities should be limits in the water, and how the different kind of time to time measurements of the water quality that need to be done in the context of the sustainable practices, in the context of environmental conservation, even in the context of Clean Ganga mission and other this kind of schemes all over the world, where that as I mentioned in the very beginning, that the civilization builds in the banks of the river. So it's next to impossible that you cannot like you disconnect the humans activities from the river. So it's next to impossible, but it is important that being along with parallelly with the human activities is also important, that time to time study of this kind of water quality improvements, and what kind of sustainable practices and environmental conservation that we provide for the improved water quality, experiments. And based on the experiments, based on the outcomes, it is important that we can take a proper needs of that particular region as need as like specific region based operations that you require, or specific region based improvement techniques required for this. So
Yes,
yeah,
yes,
that's
Subhaji. Yeah. Ah, okay, thank you.
that's all from my end from today. And thank you again very much to all of you for providing me the platform for the discussions. Thank you. Open
Thank you,
for the
Subhaji.
questions.
Yeah, thank you, Subhaji, for the presentation. We have about 9 minutes to interact, and if you have a question for Subhaji, Shubhaji, maybe you can keep your presentation up in case someone asks you to go back for a slide for a question. So if you have a question, you can unmute yourself, or you can write in the chat, and we will read it aloud for Shubhaji. So Mary Beth has a question. Mary Beth, you want to start?
Yes, thank you. Excellent presentation, especially the explanation about Google Earth Engine for those who are not familiar. I wondered, based upon your results, were there would your results argue for the use of different models at either different points in the length of the Ganges, or maybe different water types identified? Or do you desire to choose one best fit model for the
Mm.
I guess ppm that you're measuring?
Yeah. So, as I mentioned, that the models is applied on the basic specific regions of interest, and these regions of interest is based on your selection of the particular regions of interest. So, for example, if I consider the entire stretch of Haridwar or Varanasi and Sagar, it's a huge stretch. It's almost 100 kilometers stretch would be there, but you cannot do the entire stretch for that. So that's why you pick up some of the specific location, and this kind of selection of the region of interest is absolutely random. So there is no specific like water type and some specific limitations we have not put into that. So the selection of region of interest where we found mostly the concentration. So if I talk about, if you look into the picture of Haridwar, that this picture, if you look into the picture, that this is the region where the major, it's called the we call in a local language the ghats. It's actually where the steps of the has been done for the people to come into the water. So here the majority of the concentration of the peoples are into this particular region, or maybe somehow up to this. So we actually taken this part where the human activities are actually higher. If I look into this other part where there is no like population, so mostly in this part where the all the temples are there, and the steps are there, and people are taken for bath and other pilgrimage activities are there. So that's the main location where the human activities are higher in compared to the other stretch of this Haridwar region. Similarly, it's also showing in, it's not showing here, but in Varanasi also same the locations. But for Sagar Island, it's very randomized place. We haven't put into a specific location where human invention, because it's a huge area, it's a huge delta region, and it's not next to possible to consider in a specific region for the one. So yeah, I hope this is clears your answer, and yeah, let me know.
Yes, thank you. If you could go back to that last slide, I did just have one other follow-on question about that, the Sagar slide. That I see that there's peaks in February and mid-December. and it seemed to be reflected in all of the models. So I
Mm-hmm.
just wondered, is there something going on at that time? Is that a typical bloom or maybe a large meltwater
Yeah.
flood coming in?
So what I would say, this is because of the local festivals that are going on, and because of this also kind of a, as I mentioned, it's a tourism place. So like India is a very hot and
Yes.
humid country, so people are
So those
preferred
are
to like tourism
calendar.
activities during the time of the winter, which is actually from the January to like from December to till the end of February, I would say. So probably the reason this like tourism activities may be higher in this particular place, which could be a reason for the higher concentration.
Okay, thank you.
Thanks.
Thank you, Subhajit and Maribeth. We have maybe time for one more question. And Rabia asks if you could talk a bit more about the processing steps in Google Earth Engine.
Yeah, sure. So in Google Earth Engine, basically, if I tell you the proper steps. So first of all, in Google Earth Engine, you will get two kind of data. Number one is called the top of atmosphere or TOA data, which is not atmospherically corrected. That's why it's called the top of atmosphere. And another sets of data, or it called the level 1b data. And and the next part data set we received that bottom of atmosphere, which is atmospherically corrected. So any kind of remote sensing applications you will do, you have to do the atmospherically corrected data sets to remove the noise and haze and other kind of things. So this is the first part, but in this study we directly as occurred the level the top of the sorry the bottom of atmosphere data, which is atmospherically corrected already. So this is the first step, and after the data import, we selected the quality data set based on the different conditions. For example, the images should be less than 5% cloud coverage, very nominal standards of haze, and the noises in the image, and that's the final flagging that we have done into the images. We also use some of the quality bands that is associated with the Sentinel for quality selection of the data. At the next stage, we directly applied the formulas, the models which is there into the Google Earth Engine console. So there's a theoretical, like there is a model console that we prepared for that. And in the next stage, in the first stage, we received, if you look in the Google Earth Engine code editor, that you can the first stage we received based on the ROIs, we received the time series average of the locations. And the next part, we received the imagery based, the ROI based image of that particular area where you can see the spatially which part of that particular ROI is come with the different levels of concentration. So that's the main focus on that. So this is the entire scheme of the Earth Engine platform programming. Is it clear or?
Thank you, Shubhajit. We are at the end of your presentation, and I would encourage all the participants here to send you comments and questions by mail. We
Mhm.
can share your email with the participants, I believe, so that they can write directly to you. I have many questions as well that we sadly did not have time to include here, but I will follow up with you by mail. So
Sure,
thank you so
sure.
much
I'll be
for your
happy to answer.
presentation.
Thank you.
And good luck
Thank
with
you.
the position of assistant professor now that you just
Thank
started.
you.
And I'll
Thank you.
see
And
you.
may I request to Mary that when you finish that, can you share me the recording of the presentation? Would be fine.
Yes, it will be available in about 4 hours and we'll send it to you.
Okay. Great,
Okay?
great, great. Thanks.
Yes,
Great.
I'll also just mention that if anybody needs a certificate of attendance for today, one will be coming for our presenter and also our mentors. But if anybody on the call needs a certificate of attendance, just send me an email with, certificate in the subject heading, and I'll be happy to share that with you.
Sure, great.
Thanks, everybody.